Hello, everyone. Welcome to Keras Dreambooth kickoff event. I'm Merve, and I will be hosting this event. And I will be going through the details of our sprint. Just a second. Just a second. Yeah. And welcome. So the schedule for our event is that I'm going to go through all of the details of the sprint, and then we will host the first author of Dreambooth, Nathaniel Ruiz. And then we will have a short talk on KerasCV by the creator of Keras, François Chollet. And then we will have Apolinario from the diffusers team to talk about diffusers and how to train Dreambooth using diffusers. And lastly, we will have a short briefing by Nima on the Consentful category, which I will be elaborating in this talk. But what is Dreambooth? It's a technique, a fine-tuning technique for stable diffusion that allows us to create realistic images on a concept with only 5-10 photos. So if you were to, for instance, fine-tune on 100 images, like back in the day, it was too costful by means of computation and also the data. But Dreambooth allows us to create realistic generations with only 5 or 10 photos. And in this event, we are going to train our own Dreambooth models using KerasCV and create applications on them using Gradio, and we'll be hosting them on Hugging Face Spaces. There is absolutely no limitation on what you can fine-tune on. We have 4 categories as of now, and the first one is nature and animals, in which you can fine-tune on your pet or some panoramas, or there was one instance where someone fine-tuned on the galaxy images from James Webb Telescope, anything that you can think about nature. And you can fine-tune on sci-fi or fantasy universes, which is one of the most popular categories that I have seen on Hugging Face Hub. And the third category is Consentful. You can partner up with an artist and use their work to fine-tune on their own style and train a Dreambooth model with it. And we will be having a very short briefing by Nima today at the end of this event about it. And the last one is wildcard, which can be anything that falls out of these categories. And a couple of inspirations. For instance, the first one is someone trained it on their cat. And the second one is the one I have just mentioned for nature category is James Webb Telescope diffusion, which you can generate new galaxies or other space images. And sci-fi inspirations it's often that we see many game or series, sci-fi or fantasy series styles being fine-tuned on. One of them is this Elden Ring one, and then you can have this love poly isometric cyberpunk creation, and you can have Fantasy Sword one, which are super cool, but you can just use your imagination and create, fine-tune on anything. And the wildcard one is the one that you can train on anything. Like first example, is balloon art style that doesn't really fall into the previous categories. You can fine-tune on a texture, on a style, on even your own photos, which I did for myself. In here, you can see in the last one, we will accept it under wildcard category because it doesn't fall into the previous ones. And for this sprint, we have a leaderboard in the organization page, which I will post later on in the chat. For each category, we have 3 prizes, and we will be ranking all of the submissions by likes. And the prizes include the natural language processing with Transformers book, Hugging Face Pro subscription for a year, or merch from Hugging Face shop. Again, you can decide on them because we didn't force it. We didn't put a limitation on what you can actually get. And you can make as much submissions as you want for this sprint. And the deadlines are that the sprint actually starts tomorrow. This is just the kickoff event. And the sprint ends in the 1st of April. And in 7th of April, we will just look at the leaderboards and decide who won it, who won the prizes, and then we will announce them. If you want to get started with the sprint, you can simply join the Hugging Face Discord. Let me just post the link. And there is a role assignment channel. I'm going to show this. There's a role assignment channel over there. You can take the role Keras Working Group member and head to Keras Working Group channel and just join us there. And there is necessary information to join the sprint. We have a long document, and also we will be distributing free GPUs thanks to Lambda. We will be giving $20 worth of voucher, which lets you train roughly around 60 models on a A10 GPU. And the documents that we have included includes the details about the GPU grants and how you can get them and how you can SSH into an instance and train your own model and so on. So all of the details are included there, but do not hesitate to ask any questions. And this also applies to this talk as well. If you have any questions to any of our speakers, you can ask them. Let me quickly see if there is any questions for me here, and then we can move on with Nathaniel's talk. So there is one question: do we need our category approved before fine-tuning? No, you can just fine-tune and just make a submission. Even if your category, like what you have fine-tuned on, doesn't really fall into one of the categories, you can still submit for wildcard. And it's the book of Lewis that we are going to give away. It's the Hugging Face book, where you have natural language processing with transformers. And I will give my stage to Nathaniel. Let me think. Hello.
Hi.
Nathaniel is the first author of the Dreambooth paper, and today he will talk about Dreambooth. Would you like to share your screen or slides?
Yep, sure. Give me a second. There we go. Can you see this?
Yep. I'm
Perfect.
going to remove myself and hope you will have a great talk. I will also drop by at the end to see if there is any questions or anything in the chat that people would like to ask you. Cool.
Perfect. Yep. All right, thank you so much. And yeah, first of all, I wanted to thank Merve and the team, Apolinario and everyone else. Thank you so much for inviting me to this. And it's really exciting, a super exciting initiative. So I'm Nathaniel Ruiz. I'm working at Google and also a PhD student at Boston University, graduating soon. So I'm going to give a quick talk on Dreambooth. A lot of you already know what it is. So I'm going to try to go through the kind of pre-existing details, the stuff that's out there, pretty quickly, and then I'm going to present some new stuff that we have for an updated version that's coming out very, very soon. It just got accepted to CVPR, and then also kind of give maybe some inspiration of show some stuff by some friends, shows some inspiration for your personal projects probably. So the inspiration for Dreambooth is to add controls to large diffusion models. So diffusion models had very impressive quality and diversity, but were very hard to control before Dreambooth. So you have some amazing images generated, but you can't really specify, you want this specific subject in this image or this very specific style in this image. And so you can see it here, for example, using image guided DALL-E generations, using the clip guided conditioning, you get similar images, but you don't get the exact same clock that you want. Using text guided, prompt guided Imagen or DALL-E 2, you get similar clocks, but you can never get exactly the clock that you want in this case. And using Dreambooth, you are able to get the specific clock that you want. So this is kind of our main figure where you have this dog and you can kind of generate the dog in different contexts. So that was one surprising thing about Dreambooth, that you were able to do this so well. And also that it was able to generalize to different poses and articulations. So how does Dreambooth work? Well, basically, so this is explained using the Imagen model, but it works on the stable diffusion model, so on latent diffusion models as well. And basically, you have a data set of 3 to 5 input images. Now people use more for faces sometimes. Sometimes you can use less, and sometimes you can even get away with using only one image. So the idea is that you have you're going to fine tune the diffusion model. So for Imagen, it's the base model here, which is the 64 by 64 model. And the core idea of Dreambooth is you have a data set and you're going to fine tune a diffusion model using a specific kind of prompt that you give it. And the prompt is a v and then the class of the subject. So in this case, a v dog, where v is basically a rare identifier that you can select. So this works really well because it tags the rare identifier and relates it to the specific subject that you have. And also it's using this class label dog to facilitate this connection. And you do this, you just train this using the normal reconstruction laws for diffusion models. Another thing is, so for Imagen, you had these upsampling models, and you can also fine tune them for better, better accuracy for your subject. But latent diffusion models such as stable diffusion don't have these. And then you also have this prior preservation loss that we added, where you want the model not forget that the word dog. Since you're using it already for this prompt, you don't want to forget the association with like normal dogs. So you regularize it by generating images of different dogs or using images from the internet of different dogs, and then also training it on the sentence a dog with those dogs too, so it doesn't forget the concept, and it just attaches the rare identifier to your subject. So this is the basic idea of Dreambooth. You don't need this prior preservation loss all the time, only if you require certain things, such as preserving the prior, and sometimes it gives more diversity. But the core idea of Dreambooth is here on top, basically fine-tuning a diffusion model using a rare identifier for a specific subject. So some new things that we have, that's the stuff that was on the archive release version. So now for a CVPR, we have some new stuff that is being released very, very soon. So a data set. Right now, this link doesn't work, but it will work later today. So I think I'm uploading the data set today, and then we're updating the archive version tomorrow, I believe. So on Wednesday, it should be there. So this could be useful for your project because we have a data set of 30 subjects where we have 3 to 6 images per subject. 21 inanimate objects and 9 pets, and then we also have a set of associated prompts. So this is a data set that could help you evaluate your specific model. So if you have models for style, then you can try to evaluate them on these subjects. And that's a good, there are no other data sets that have kind of this variety of subjects and also several images per subject in different poses and contexts. So that's the interesting thing about this. Yeah, we also have the prompts. So you have 25 prompts for each object, for objects, and 25 prompts for live subjects, such as pets. So some quick things about that are in the paper that's going to be released soon. So the updated version, which are comparisons to textual inversion. Textual inversion is another method that backpropagates onto the embeddings of the text tokens that are going to be the input of the diffusion model. And the idea is also to get a consistent subject or concept, and sometimes it can fail without added regularization, and it's a little bit more finicky sometimes than Dreambooth is. It does have some advantages, so the embedding is really small compared to a full Dreambooth model, right? So, but sometimes for rare subjects such as this one, this face, Dreambooth performs better. And then in the new version, so I'm going to go quickly through this, but basically you can check it on the archive version in a couple of days. We have some new metrics. So we come up with this dino metric, which is basically cosine similarity of dino vectors for images that are generated and real. And this helps for subject fidelity, so seeing if the same subject is represented in different scenes. We also use the clip image and clip text metrics, and then we see that basically Dreambooth for Imagen was the best one, and then Dreambooth for Stable Diffusion came second. In the paper, we also have this new user study where we queried 72 users with a bunch of questions. So we have 1,800 answers in total, and we saw that Dreambooth is better than textual inversion for qualitatively for subject and prompt fidelity. Okay, so these are some of the figures that you might be familiar with that are in the original paper. So object recontextualization, you can grab a subject or object and then put it in different scenes. That's one very interesting application of Dreambooth. You can have artistic renditions in different styles that are already kind of baked into the model. You can have, text-guided view synthesis, which was a pretty surprising thing about the project. Property modification, such as there's different colors of cars or hybrids of dog breeds with other animals, and then accessorization. So a lot of these you might have already seen, such as the comic, for example. This is also coming out in the new version. And then this you might not have seen. So we did also a study of like how many samples do you need, and actually I encourage all of you to experiment how many samples you need. Because already with one sample, sometimes we were getting pretty good results. And 2 samples already for this dog worked really well. So for some specific subjects, you don't need that many samples, which is very interesting. This means like the prior is really, really strong for some of these diffusion models. Okay, so I'm coming to the kind of interesting part of the talk, in which kind of I give you some examples of that some friends made on Twitter, that they've been sharing on Twitter about their Dreambooth models. And first, I'm going to do kind of this application-driven exploration phase, where I'm going to show you some applications, and those are things that you might want to fine-tune on, give you ideas to fine-tune on to do cool things. So one amazing thing was very early on, Emmanuel started doing this video game asset generation. So there's a startup scenario.gg where they generate these video game assets, which are amazing. So isometric assets or like mobile game assets. And now they have their own app where you can kind of generate new assets for video games. So I thought these were really cool. Also very early on, there's DALL-E 2 Pictures that was kind of like inserting his own face into movies using inpainting in an incredibly realistic manner, which wasn't really doable before, especially with few images of a face. Then this whole like popular movement of AI selfies came about. So this New York Times article about how to do this. I think there was an app that was very popular for this. So this is credit to John Barron for giving me these images. This is what you can achieve with it. With few images of one person, you can kind of generate new images, very accurate images of someone's face in different styles, which is very cool. So Kali Yuga made these custom enamel pins, which I think are really cool. Like I think maybe like the AI portrait thing. The AI portrait thing is already a lot of people have done it, and there's so much kind of potential for other things, such as these these, object-driven explorations, which are really cool, like artistic-driven explorations that I think are really, really cool. I skipped this one, so not on purpose, but yeah. So Roop has some amazing, realistic, artistic images that he generates of people. So these are all, this is a Dreambooth model, but it's all kind of realistic faces um, that look amazing. And then, this, I think this is the last one. So Ben Scott Pye from these thematic plushie creations. So just fine tuning a bunch of weird plushies. I think he fine tuned it on, so this is like a example of a feedback loop. I think he fine tuned it on images that he generated using DALL-E 2. So he first generated some cool images using DALL-E 2, and then he generated a Dreambooth model, a stable diffusion model of these images, and then he could generate much more variety. So there's like a weird feedback loop here, but you can still get really amazing creations using that. And then finally, to finish my talk, I think I went a little bit under the time, and so I'll have more time for questions, and also I can like revisit some slides if anyone wants to. But there are some technical frontiers that I think are interesting. So if you're not just interested in fine tuning on a specific topic and then uploading your model, there are some things I think for specifically. So this is like a Keras Dreambooth sprint, and I think Keras has a lot of unexploited potential, especially when it comes to diffusion models. I think they put out one of the fastest kind of like training and testing and inference of diffusion models of stable diffusion very early on, and I think there's a lot of unexplored potential here. So I encourage a lot of you to kind of like maybe make up new tools for Keras related to diffusion models and Dreambooth. That would be really amazing. So here's some technical frontiers of Dreambooth that you can explore using Keras. For example, one thing about Dreambooth is that if you do vanilla Dreambooth, so now there's like, later versions of Dreambooth use less storage size. You could basically only fine tune specific layers, which is another way of generating a Dreambooth model. You can just fine tune, for example, cross attention layers, which is pretty obvious way of doing it. And that would generate a smaller size model that still pretty much works. So you can try to explore the side of lowering the storage size and the model size, for example, using low dimensional update approximations. And another frontier is GPU memory reduction. So like reduce the memory necessary to the GPU memory necessary to train one of these models. And there's a lot of different ways of doing this in PyTorch, and a lot of people have already explored that. But now with Keras, there might be like a lot of very interesting different ways of doing this. And this really helps a lot of the people that don't have huge GPUs to do this, right? So I encourage a lot of you to explore this as well. So try to lower the time spent training, so make the training faster. And that can be, there's a lot of different kind of ways that you can think about that. You can think about the scenario, like a training scenario, change the prompts, etc. Or there's a lot of different ways to do that, which I encourage you to explore. Another huge frontier is like, can we get these models on device? And I think Keras has some packages that allow you to deploy on device. And that would be really interesting to see some of these models be able to be deployed on device. So a lot of things that you need to do there is like a lot of these previous things you need to achieve in order to get them on device. Like the model size has to be smaller, and also you have to have like faster inference, for example. And then the last one that I think no one has kind of cracked yet is generalization. So right now, a lot of people do early stopping for Dreambooth, and they kind of like fine tune the hyperparameters a lot. So like they tune their hyperparameters in order to get really good results on a specific subject. And I think the next frontier is having one recipe or formulation that fits kind of like a lot of different subjects. So you don't have to, so this basically doesn't stay as an art, it becomes like a science a little bit. And that would be kind of the next step there. All right, thank you very much. I want to thank all of my collaborators, Kfir, Varun, Yunjin, Mickey, and Yael. All of this is thanks to them. Also, a lot of the people that we acknowledge in the paper that helped proofread it and give ideas, and then just kind of facilitate the process of getting all of this out there. And again, finally, I want to thank the Hugging Face team for inviting me. I think this is a great, again, I just want to emphasize this is a great initiative because a lot of the Keras potential has been untapped in this area. And I think once it gets tapped, you might see another kind of like small explosion in the creativity space for this. So yeah, and good luck to François later for his presentation. So yeah, Merve, if you have any questions for me, I'd be happy to take them.
Hello. Yeah, sure. We have a couple of questions. The first one that I picked is, to train a Dreambooth model, how many images do you recommend to train with? Is it necessary to have the images and prompting for the data set?
Okay, I understand the first part of the question, and the second part I'm like less sure that I understand. But the first part, so how many images do you need? I think I would usually start with stable diffusion. I would start with 4 or 5, and then see if that works, and then you can kind of tune around that. And it depends really on the subject, right? Yeah, it depends on the subject or the concept. So if you're doing art styles, I would say more. Much more because you need sometimes the model doesn't have a strong prior for that specific art style, and it really needs to learn it, right? So it needs a lot of diverse examples for that. But for faces, it has a really strong prior. It's just that faces, we're very good at recognizing whether a face is the person that we think it is or not, like, so we're very good at discriminating faces, so that maybe that's why you need a little bit more images, like in the order of 10 images for faces. But for other objects, sometimes you only need 5 or less sometimes. So I would really explore that, but I would start with 5 in the usual subject case. So is it necessary to have the images and prompting for the data set? Again, so the prompt, for Dreambooth, you have a specific subject, and then the prompt would be AV and then the class name. And sometimes that class name isn't even necessary if you train it for long enough. You can try to tune the hyperparameters for that. So you don't need prompts for your specific subject. Yeah, and if this is talking about the dataset that is going to be released, then the prompts for generating those images will be there.
Thank you. Christopher has asked, how does it feel to have your work have such a huge impact outside of research community? I think it's very
That's
cool.
a great question. Yeah, I don't know. I'm still like just completely blown away. It's super surprising. So for my perspective, I just I was a little bit in a state of shock for like the first couple of weeks when it kind of blew up. But then, yeah, I really appreciate that I made really great friends that are making art and really amazing applications. That's one thing that I loved from my perspective. And it feels good. It never intended it to turn out this way, and now it just gives me more motivation, I guess, like keep trying to do that and seeing people just enjoying kind of these things. So yeah, I think that's the answer. But it is a little, when you're a researcher, you're not usually kind of like expecting this. You're just, working on something like a paper. And when it has this like wide ranging impact, it feels good, but it's also kind of like a little unsettling, I guess. And it's hard to get used to.
Yeah. Last question is from Apolinario, and it's, do you have any high-level tips for hyperparameter tuning, lower, higher learning rate, how to find optimal steps?
Yeah, so from my perspective, like as a researcher, and this is not shared by almost anyone, obviously, because it's like we're doing very different things. I I really dislike hyperparameter tuning, and I think a lot of people are just way better than me at that. So like we released Dreambooth, and then artists and everyone else kind of became really really good at training models before we did. So because we were thinking about more the technical aspect. So the way I think about this is like, hopefully it doesn't exist soon, like hopefully hyperparameter tuning doesn't even exist soon because we have better techniques. But but it's still like a necessary thing to do. So I do still have to do this, but I don't think I'm the best person to ask. I think there's like people that are, I'm probably you're way better than me actually at this. But yeah, so I guess how do I do it? I guess one thing that I would say is just like it's really hard to evaluate these things. So whenever you have a Dreambooth model, it's really hard to say whether it's a good one or a bad one. So try to find a way to like distinguish a good from bad model by having like a test suite. And you generate your test suite of things, like a lot of diversity in the prompts, and then you kind of have to like eyeball it and say, I like this model, like this model is good. Like maybe you can rate the models and have and log all of your experiments. So just obviously like the typical thing, just explore one parameter one by one and log all of your experiments like in a spreadsheet and have like, okay, this experiment I changed this thing, and then this model does as good or worse or better than the previous one. And that's kind of like how you're doing this like weird gradient descent thing where, you know, student gradient descent, where you're trying to like tune these parameters. But I think a lot of that's the good thing about Dreambooth right now. Stable diffusion is like a lot of these things for a lot of subjects just work out of the box, and you just need to tune them a little bit to get them to work really, really well.
Thank you. Thank you so much for joining us today. I really liked the presentation and the further things that we can actually explore with the Dreambooth. And thank you so much for your talk. I really liked it.
Thank you, Merve. Yeah, no, this has been awesome, and yeah, good luck with everything.
Thank you. See ya.
Bye.
Now we will have François Chollet. Let me do this. Hello.
Hi everyone. I'm François from the KerasCV at Google. Yeah, and thanks a lot, Nathalie, for the great talk. I really enjoyed it, and congrats on the awesome contribution to generative AI. This is like really, really awesome stuff, very impressive stuff. I'm gonna share my screen.
Yep.
All right, you should be able to see my screen.
Yes, thank you so much. And yeah, I'm going to leave you for your talk. Thanks a lot for joining us today.
Yeah. All right. So yeah, just want to say to start with, thank you to everyone being here, contributing to Hackathon, and also thank you to the awesome folks at Hugging Face for organizing the Hackathon. So my talk is really quick, just to give you some quick context on Keras and the KerasCV package and the stable diffusion implementation that we have in KerasCV. So what's KerasCV, first of all? Well, it's a first-party extension of the Keras API that's focused on computer vision components. And we aim to cover 3 types of workflows in particular. So the lower-level workflow, where you can just compose your own pipelines and do training and eval on your own data set from scratch. And also a slightly higher-level type of workflow when you're starting from pre-trained components, like a pre-trained RetinaNet, for instance, that you can fine-tune on your own data. And finally, just a more like ready-made inference type workflow when you can instantiate an existing model, let's say, for instance, an OCR model, and you can immediately start using it, and you can start serving it on different surfaces, so meaning like server-side, on a mobile device, in the browser, and so on. And if you're into NLP as well, then you should know that there's also a sister package of KerasCV, which is KerasNLP. KerasNLP is actually slightly more mature at this time. So if you're into NLP, check it out. So KerasCV is very much a work in progress at this time. And right now, our current focus is mostly on pre-processing layers. We have a wide range of about 40 different pre-processing layers. They don't just process images, they also process bounding boxes and segmentation masks, which is usually pretty difficult, pretty annoying to do. So in this case, the package just does it for you. We also have about 15 different backbones. So backbone being a pre-trained feature extraction model, something like a ResNet 50 v2 backbone. And something that we are starting to do, but that's not very mature yet, is models. So right now we have a RetinaNet model, we have the stable diffusion model, we're adding faster RCNN, we're adding segmentation models, we're adding OCR models, and so on. We also have a couple metrics like Coco metrics and so on. But it's not really big focus at this time. Like we're already starting with pre-processing workflows and backbone models. And the goal is really that in the long term, we want to provide you with a toolkit where you can quickly assemble any computer vision workflow in just minutes. So mostly detection, classification, segmentation, but not limited to that. We're going to see more use cases like OCR, for instance, in the future. And we want to cover not just 2D images, but also 3D point clouds. So 3D point clouds is something that might seem a bit niche. I suppose the reason we want support for 3D point clouds is because Waymo is a big Keras user. So Waymo is the autonomous vehicle arm of Alphabet. They're the company that provides the first fully driverless taxi service that's currently operating in Phoenix and in SF, where you can basically just book a ride in the Waymo app, and you get a vehicle, a car with like no driver in it, come to you, you get in it, it gets you to a destination with no human involved. It's pretty unique. It's the future basically, and it's all built with Keras models. And so for this reason, we wanted to add support for 3D point clouds. So obviously, LiDAR data is all 3D point cloud. So Waymo is really just starting to adopt KerasCV at this time, but they're already a big Keras user. So besides just components for creating like CV workflows from scratch, we're also going to include pre-trained components. And so starting with backbone models, but also moving towards higher level, more end-to-end models in the future. And we don't just want to provide models that you can use, we want to provide models that can retrain. So for any checkpoint that we provide, we want to make sure that the scripts are there so that you can reproduce the same training results, that you can kind of check out how the training was achieved. Like you can look at the TensorBoard logs, you can look at the hyperparameters that were used for training and so on, which is really helpful if you want to train your own model on your own data set. You need to know exactly how the original checkpoint was achieved. And lastly, we want to make sure that it's fast and production ready. Like we want it to be a package for production. The focus is really on applied ML. So that includes making sure that all models are compatible with mixed precision and with quantization, which is really like a must-have if you're going to deploy your model. Really optimized on GPU and TPU as well, so all XLA compatible, and inference ready, so compatible with TF-Lite, with TF.js, so that you can bring your model into the browser, TensorFlow serving, TensorRT, and so on. And so a quick reminder that it's very much a work in progress. It's not a mature package yet. It's moving fast. And if you want to contribute, well, we welcome new contributors. So right now we're working on stuff like the YOLO models, we're working on segmentation models, and some mobile deployment demos as well. And one of the models that we have in KerasCV right now is Stable Diffusion. And it all started as a community effort. So Divam Gupta, very quickly after the original Stable Diffusion release, made a port of Stable Diffusion to Keras. And we kept working on it, and it got officially merged into KerasCV in August. And so today it supports Stable Diffusion v1, Stable Diffusion v2. It does text to image and in painting out of the box. And we also have tutorials that show how to do textual inversion, Dreambooth, of course, and fine-tuning the Stable Diffusion model. And if you're not familiar with Keras, so you assume most of you are probably familiar with Keras, but if you're not, definitely do check out the code. It gives you a pretty good idea of what writing code in Keras is like. So there's a focus on conciseness, readability, modifiability. I think it's really elegant code. The entire project is only about 600 lines of code. And the diffusion model itself is like 320 lines. So it's really short, really easy to read. It's a pleasure to work with. So do check out the code itself. I think it's really good code. And it's also very well optimized code. So it supports XLA compilation out of the box, meaning you can run it on TPU. This is really helpful if you're doing batched inference. You can cut your serving costs quite a bit that way. It supports M1 MacBooks and M2 MacBooks out of the box as well. There was like no particular special casing that we had to do to get XLA compatibility or ARM compatibility. It just worked. It's also ready to export to TFJS and TF-Lite. So we have it running in TFJS. It actually runs quite well and it's decently fast. It's GPU accelerated in Chrome. It does require a lot of RAM, so it's going to eat up most of your RAM. You have to run it on a big laptop. But it actually works quite well in Chrome. So it also, you can export it out of the box on TF-Lite. We have it running on a Pixel 6. It doesn't actually run very fast, mostly because it's largely not hardware accelerated. At this time, it's mostly running on the CPU. So on the Pixel 6 Pro, I think it takes about 10 minutes to generate one image. So it's basically too slow for real production usage. I think if you want to use it on a mobile device, you would need to adapt the model. So for instance, I know Apple made a full rewrite of Stable Diffusion to run on iPhones and so on. And the advantage of the KerasCV one is basically you don't have to do a full rewrite if you just want to prototype your mobile app. Like you just write the model with no special casing of mobile or TFJS or and so on whatsoever. And then you can actually just move it to mobile. It's not going to be fast, it's going to be optimized, but it's enough to prototype. And if you like what you see, then you can actually do the rewrite. So this is like all of these features, TFJS, TF-Lite, ARM support, XLS support. It's all out of the box. There was no special casing needed. So do check out the code. It's on GitHub at keras-team/keras-cv. And on keras.io, you will find a bunch of tutorials. We have just the basic text-to-image intro. We have tutorials about how to do latent space walks, which is what you see on the image on the right. So you take 2 points and the latent space, and you kind of walk along a path between these 2 points and to generate like nice little animations like this. You can do texture inversion, Dreambooth, and you can fine-tune your Stable Diffusion models. And one thing I wanted to mention is that really Keras is all about community. It's all about people like you. We are a very small team at Google, and none of what we do will really be possible without community contributions. Everything we do is a community effort. So in the case of Stable Diffusion and Stable Diffusion tutorials, I'd like to thank in particular our Keras community members, Sayak, Chensung, and Divam. So Divam started the original Keras part of Stable Diffusion. Sayak and Chensung contributed a bunch of really great tutorials. And on the side of the Keras team, Luke and Ian made awesome contributions as well. So good luck, and I hope you have fun building stuff. Thank you.
Thank you. I see no one has any question, but I do have a few questions. So I wanted to ask, firstly, for instance, when you're loading a model from TF Hub with Keras Layer and directly use it, like how much interoperability does it have with KerasCV as of now? Because normally what I used to do was I was normally loading the models from keras.models. And is there going to be, because TF Hub introduces more and more models compared to just implementing these models as script inside Keras, which requires probably a lot of code reviews and stuff. So is there going to be any flexibility and maybe even loading from Hugging Face Hub directly? How does it, do you have any plans in roadmap?
I don't think we need plans for that. I don't think we need special casing of it. KerasCV is not a new framework. It's really just a toolbox of Keras components. So everything in KerasCV is just a Keras component. And when you instantiate like a Keras layer that you use to load a TF Hub model, it's just a Keras layer. Same for Hugging Face models. So you can use them together. Like there's no restriction on that. If you want to take a Hugging Face backbone, for instance, if you want to take a TF Hub backbone, put them in a KerasCV model, that's just going to work. So no like special casing in the roadmap needed. I wanted to give maybe a little bit more context for those who don't have context on the call on TF Hub in particular, and what's different between like a Keras model, like the kind of model we may have in KerasCV, and the TF Hub model. So a regular Keras model is defined in Python code. When you load the model, you literally just instantiating the model by running the Python code, and after that, you're learning the weights. On TF-Hub, it's slightly different. The model is stored as a static artifact. So it's basically a binary blob, including weights, including a computation graph that's baked into the artifact. And when you load it, you're basically reinstantiating an abstract TensorFlow graph with weights loaded in it, and you're basically putting in front of that a Keras layer interface so that you can manipulate the revived model, the revived graph via the Keras API. So it's two very different ways of doing things. So obviously, it's if you want to build a model platform where anyone can upload their own models, it's much easier to do it the artifact way because you just have to upload files. Basically, you don't have to upload a code base, meaning that there's no like code review step and so on. But it also means that you have less flexibility because you cannot inspect the code, you cannot modify the code, you cannot do things like extracting features from specific layers and so on, because it's really just a black box artifact.
Cool. I have one more question that is sort of answered, like half answered in your talk. I wanted to ask, what is the expected time interval to expect in complete interoperability of TensorFlow Extended, TensorFlow Serving, or Lite with KerasCV?
Right. So if you have a Keras model in general, so not necessarily a KerasCV model, it's always going to be exportable to TF serving in basically just like seconds or minutes. When it comes to TFJS and TF Lite, it depends on the model. So for the KerasCV models, we have this commitment that they're all going to be exportable to the browser and to a mobile device out of the box. But if you have just an arbitrary model, it kind of depends. So the models that we've tried so far in KerasCV, they could all run out of the box, but it's not always the most performant, right? I think that's especially true with TF Lite. The thing with TF Lite is that there's only a subset of the TF Lite ops that are hardware accelerated, and your model needs to be built entirely with these ops, basically. When you export to TF Lite and TFJS as well, one thing to remember is that you probably don't want to export your raw model. You want to export an optimized version of it, not manually optimized, but automatically optimized with things like quantization in particular. So we have a package that's called the TensorFlow Model Optimization Toolkit, which provides a bunch of functionality. You can just, bring your Keras model, run it through, the quantized wrapper, for instance, in the TF Model Optimization Toolkit. It gives you a new model which is more lightweight, uses fewer flops and so on. And that's the version that you should be exporting to TF Lite or TFJS. It takes like the end-to-end deployment process takes like typically under an hour.
Thank you. And one last question is from chat. Do you mind talking about roadmap of KerasCV towards image segmentation and maybe video segmentation later on ahead?
Sure. So right now we are focused more on object detection, but image segmentation is the next thing we are going to be doing. Video segmentation is definitely on the roadmap, not the near-term roadmap. We have very, very few people working on this stuff. And by the way, we're welcoming contributions. So if you want to work on video segmentation, your contributions are welcome. We can work with you to ship that. If we are shipping it, then it's probably going to take at least 6 months. Like we are focused on other use cases first.
Thanks a lot. Thanks a lot for joining us today.
Thank you. Thanks a lot for having me.
Thank you so much. See ya. We will now have the talk of Apolinario from Diffusers. Apolinario, are you there? Yep. Hello.
Hello.
I will now leave you with your talk. If it's okay, can you share your screen?
Yes, it is shared. Okay. Can you
Yep,
see it in full screen?
works. Yeah.
Is it in full screen or
No, it's on. It's only. It's only the interface with the slides inside and not the slides themselves. I think this should work. I'm going to leave you to it.
okay?
Good luck.
Hi everyone. So
Your screen is gone now. Just a second. You need to
Oh.
share again. I'm sorry.
oh sorry, something has gone wrong. Can you see it now, maybe?
Yes, I'm going to leave you to it.
Okay, yeah, sorry for that. Hi everyone. I will be here talking a bit about the diffusers library. After these two amazing presentations, the first one on the Dreambooth technique and the new things coming to the paper, I'm very excited to see those that updated paper, and then the amazing talk on the Keras library and the philosophy behind it. I decided to talk a bit about the diffusers library. Since this actual sprint will not be using the diffusers library because it will be using KerasCV, which diffusers does not support just yet for TensorFlow, I will talk a bit about the philosophy behind the diffusers library because I think it can be pretty expandable to any framework. So it just doesn't support it right now, but we hope to add support to more libraries in the future, and also you will see how the philosophy of the diffusers library could be used even in the current iteration of what we are doing. So first of all, I'll start explaining what diffusers is, right? Diffusers is a modular toolbox for inference and training of diffusion models, right? So that means that the goal there is to put different contexts of diffusion models in one easy to use toolbox. This is just a slide of a very quick reminder of what diffusion models are. I'm sure this audience already knows it, but just in case, I'll go very quickly over it. Diffusion models essentially are models that do a denoising diffusion model process using a denoising process. So you train the model to essentially predict the noise from a random noise. You input it in a random noise, and then you try to predict what noise will be removed until you do it iteratively until you get an image. And why was diffusers built? Well, diffusion models started getting state-of-the-art results in generative synthesis, mostly for images, but also in other domains like sound and even like human movement and other strategies. But they don't use transformers, so diffusion models are a new class of models, and therefore we couldn't simply include that in the transformers library. It was too far apart from the transformers library context or concept or philosophy. But we had a similar set of challenges as with transformers. So each model implementation had its own research code. Models were scattered with different formats. So like each person that would release a model would have a different format, a different structure. So diffusers just made sense. So the team led by Patrick started this process. So there are a few philosophy for diffusers that I'll go over it. One is usability over performance. And what usability over performance means is that diffusers prefers to be easier to use and more compatible over being ultra performant out of the box. So what this means is that when you use diffusers, essentially the idea is that it will always be loaded on the maximum precision of the model. So if the model is, for example, trained on FP32, it will be FP32, even if FP16, for example, is faster. It will also be usable on CPU out of the box. So you could basically, the idea is that it's the most usable out of the box. But why did I include the meme on why not both there? It's because even though that's the philosophy out of the box, diffusers includes a set of suites to make the models ultra performant on memory and speed. So actually, the diffusers are a fast way to use diffusion models. Even though the philosophy is usability over performance, you have to like go extra steps on the code. We don't ship like the ultra the ultra optimized version out of the box, but with some optimizations that we include on the examples, you can get super fast performance. There is also the philosophy of simple over easy. And this means that we follow a bit the philosophy that explicit is better than implicit code and simple is better than complex. So a lot of people think, well, but simple and easy are a bit of a synonym, but actually what we mean by this is just that if something looks simple to follow, to use, to look, even if it's not that easy, that makes more sense for the library. So the idea is that even if it's a bit harder, but it's simpler. That's how the global philosophy of the library goes. But we will see that has one exception down the line. And the most controversial or different way that the diffusers library that borrows from the transformers library approach is that it's a tweakable and contributor-friendly process over abstractions. And what it means is that it adopts an important design principle of the transformers library that we prefer copy-pasted code over hasty abstractions. And that's a bit of a contrast to the popular design principle that such as don't repeat yourself, where it should be all modularized, the code shouldn't ever be repeated. But for diffusers and borrowing from the transformers library, we think that the self-contained unit models or pipelines in the case of diffusers make a lot of sense because essentially it allows new people to contribute really easy without having to go through the learning curve of learning the whole body of knowledge of the dependencies that the model has and all the different classes. So basically every time you want to contribute a new model, you can just study a previous pipeline that was made, copy paste it and modify it. So you have single contained units. And in a community-driven library, this makes a lot of sense as opposed to, for example, libraries where are led by an organization or a company or big teams. So it's a we follow that on diffusers, and more specifically on each of the anatomy of the diffuser models, we have a few different components. So we have models itself. So those are the types of architecture that diffusers support. So when we talk about models on the context of the diffusers library set, these are not necessarily, for example, stable diffusion, but actually the UNet to decondition model that stable diffusion uses for UNets that you expect to the images are considered models over diffusers. Then there are pipelines, and pipelines are essentially what loads the different components for specific like abstractions, like the stable diffusion, for example. The stable diffusion text to image pipeline, for example, is one of the most used ones. And the pipelines, they are made to be more like examples. So they are made to be essentially self-contained examples on how to combine models, which are like the UNet2D of the stable diffusion plus the VAE plus the noise scheduler plus and then using that all together. So those are the ideas of the pipelines. We have more than 15 pipelines currently for stable diffusion, including techniques. For example, right now we just included the control net pipeline. So every time there is a new technique on the stable diffusion space or on the diffuser model space overall, for other models, like there is a very good DALI 2 replication model called Carlo. If you don't know it, I would highly recommend you to try it out. it's an outside of Stable Diffusion, just to show that this ecosystem of diffusers is not only for Stable Diffusion. Then we have noise schedulers that are essentially the schedulers for you to remove the noise from the image that we have, for example, the DPM, PNDM, Euler, and all this different schedulers to removing the noise. And on diffusers, we also include training examples. So for popular libraries and technique training, for example, diffuser, Dreambooth, we have training examples that follow these principles and structures that I mentioned before. So yeah, as I mentioned, diffusers is currently PyTorch only, but for the relevance, I think, of diffusers for this talk and for overall this sprint that we're going through, even though it's not going to be using diffusers as it is, because we are going to focus on Keras. I think it's cool to see that, for example, Sayak, one of the contributors for Keras for Stable Diffusion, and also the person that built the Dreambooth Keras library, our colleague at Hugging Face, he essentially, there is this quote by him that he says that for him, the diffusers training script gave him confidence to re-implement it in TensorFlow. So you can see that all the philosophy elements that I've presented that led up to here lead up to what one way to do the Dreambooth that we could use on this event. So yeah, I think that's a bit of the philosophy. I hope that we can expand the library towards more supporting more code soon, or more libraries soon, such as not only using PyTorch. Currently, we have PyTorch and a little bit of JAX, but we definitely would look forward to also potentially even community contributions, and in the future supporting more libraries such as TensorFlow and Keras. But I think the philosophy can already be applied right now to whatever you're doing in the space. So yeah, thank you so much. I'm looking forward to see if there are any questions or any further comments from Merve and anyone else. Thank you.
For you, I think there is no questions as of now, but maybe we can wait for 1 minute. We are right on time as of now. Let me see. There was one question about, I don't know if you checked the Keras implementation, but there was one question about the comparison between that implementation and the diffusers one. Just
oh yeah, the question by Siraj Ashraya, right? I think that's, I'm probably.
Yes. Can you answer this?
Yeah, so I actually I can't compare the implementation of KerasCV with the diffusers one, because I haven't checked the Keras one in depth. But one thing that I can say about this is that I think Keras has been doing an amazing job on optimizing their implementations on different hardwares, which have been proven very successful to the community. And I think that overall, the latest optimizations, both for Keras and for diffusers, are showing very competitive results on speed for production. I think, as mentioned on the library philosophy, probably if Keras is up, as François said in his talk, if Keras is more focused on like having production ready to use code, that is a difference than while the diffusers library doesn't have that immediate focus, even though you can deploy your diffusers code to production as well, and that's also encouraged, and we have many ways to do that very effectively. As mentioned in the let me go back, in the like usability versus performance slide, it will not be out of the box. It requires some user tweaking to deploying it to the best of their outcome. So I think that's one more, let's say, not implementation, but like philosophical difference on the libraries. And also I would say that at least on diffusers, we do make sure that the implementations of any models that are on diffusers follow exactly the original paper / code implementation. So for example, on Stable Diffusion, if you run the code on diffusers, you get exactly the same image as you would get on the original code base, on the comp base or stability AI code base. So that's we guarantee like parity, so you can like replace it. I cannot speak about how the Keras does it, but just that's another way to like understand how diffusers implement Stable Diffusion on their environment.
We have another question. Are we going to support Keras with diffusers? Not sure if it already exists.
Yeah, currently diffusers does not support Keras. Our other library, Transformer, supports TensorFlow.
Yes.
But for diffuser, right now we are focusing on building it. Yeah, I think we're not at the stage yet to incorporate more libraries as of now, but that's total. It's not out of the question completely. I think it really depends on how the community interest for this would grow, as well as with how many maintainers we could potentially add to that. So that's definitely on our radar. I don't think it's on our short-term implementation plans to include that support right now. But we are also happy to see the ecosystem of the KerasCV growing with Stable Diffusion, and as Sayak did, I think if we can borrow philosophies from one to the other and exchange knowledge, even if the library does not support it right now, I think that's still very powerful. But yeah, I think that in the future it could be that we support more libraries, including TensorFlow and Keras.
Thank you. I think we don't have any more questions. Now I'm going to have Nima. Thanks a lot for coming, and
Thank you.
This was a very informative presentation. Have a nice evening.
You too. Bye-bye.
Bye-bye.
Hi, everyone.
Hello.
I'm Nima. I'm an ethics engineer over here at Hugging Face. Merve, thank you for having me. I'm super stoked about the Keras Dreambooth sprint. I'm really, really excited to see what y'all put out there. And I'm here to give two little slides about the Consentful prize category that we have for the sprint. So just as a little bit of like an overview, Hugging Face cares a lot about ethics. Case in point, we recently put out the ethical guidelines for developing the diffusers library. And so I highly recommend you go and check out the blog post. But that post, that guideline, it really documents like how the diffusers library is being developed. But I would love for people to take those ideas and carry them out into how they use diffusion models more generally. So we have a set of sort of like high-level categories ethically that we've been putting together. To learn more about these specifically, you can go into hf.co/ethics or huggingface.co/ethics, and you'll see a page that sort of lists out our ethics like initiatives in general. And we've broken them down into like rigorous, consentful, socially conscious, sustainable, inclusive, inquisitive. They're all quite different, but in some ways they overlap. And today for the Keras Dreambooth event, we're specifically focusing on consentful submissions. So we really want to encourage machine learning that is done in partnership with people who are affected by it. In the context of diffusion models, that can mean artists, or it can mean people who are, put into models, so models that might be used as subjects. So when we're talking about consentful machine learning in the context of the Keras Dreambooth event, I would love to put this out there for you to, integrate into your submission process. If you have found some art that you really, really, really like, if there's an artist that you're just a very, very big fan of, and you are particularly interested in reflecting their art through a model, my suggestion is, and the prize category recommends, that you go talk to the artist first. So for this particular category, whoops, I'm going to close that. There you go. For this particular category, all that you have to do is reach out to an artist, get permission to use their style, and then if you go ahead and use their style or their art for your submission, make sure that you include proof in your Space's README file that links to something that proves that the artist gave you permission or proves that the artist collaborated with you on it. So that could be a link to a tweet. It could be a link to maybe the artist's website where they have an official statement or something like that. So, you know, I'm happy to answer any questions around this, or if you raise stuff in Discord, we can help you out with it. But the basic idea is ask, and you get, you know, another prize category that you can submit for. So that is about it for me. I'm going to pass it back to Merve, and thank you again for having me.
Thank you so much. I think there is no questions for you, but if we receive on Discord, I will ask you, or like they can directly ask you. Thanks a lot, everyone, for joining us today. This is the end of our stream. Hope you liked it. If you liked it, and if you would like to join us, head to Hugging Face Discord, and in the role assignment, you will see Keras Working Group member. Take that and meet us in Keras Working Group channel so that you can get started with the sprint. Thanks a lot. See you.